Hi, this is Ms. Gonzalez. Today's lesson is going to be over the graphs of logarithmic functions. And we're going to look at how the transformations look. So take notes along with me, and then you are going to try your Pearson assignment. Okay, so here is a screenshot of the graph. The blue is your exponential function. Your black is the logarithmic function. We talked about how they were inverses, which is how we know that they are a reflection over the y equals x. So today we are going to concentrate on how the logarithmic functions look and how this graph, the black graph, is going to move based on the transformations. Okay, so I included this part of the slide so you could take a second, pause the video, write down any of this that you may have gotten confused about on your last Pearson homework assignment or classwork, however you want to look at it. So all these properties were applied in that assignment, and maybe you were still confused of something. Make sure you have these properties somewhere. Take a picture of it, keep it somewhere safe. Again, this is another basic. This other page was on logarithmic with any base. This property page is saying your base is 10. So the big thing here is to remember when there is not a base listed and you can't see it, then it is base 10. So the little number here that you can't see can be any number I want it to be. When it's not written, because we know mathematicians tend to be lazy, 10 is the number that is the lazy number that is not always seen. So whenever we mean base 10, we don't talk about it. We don't formally write it down. This is what your calculator is based out of. Your calculator uses base 10. So in a couple of lessons, we're going to start looking at the change of base to how can I evaluate if it was, say, base 2, base 3, etc. So there are ways to use your calculator. We will be learning that shortly. As of for now, if there's not a base, we call it base 10. Here is your natural logs, which remember this is just saying log base e. So again, I am quickly going through this page. The hope is that you are either rewinding the video or pausing the video to write it down. Natural log has all the same properties as the previous slides, except now your base is e. So the first slide showed you what if it was any base. Second base showed you how mathematicians are lazy and the base 10 is not written. This one is showing you that your natural log, which is base e. Now let's look at some of the transformations. So here are your two logarithmic functions. This one is going to be base 10. Blue is your base 10. And the ln is your base e. Okay, things that I want you to notice. Hopefully you are noticing all of the initial here of a would be 1. So initial is a equals 1, which is showing you how you are starting at x equals 1. So all graphs start at x equals 1. I want you to also realize here there is no horizontal because it is the inverse. We don't have a horizontal asymptote, but we do have a vertical. X equals 0. To start with, those are our asymptotes. Now, that can change as we go. You should be writing this down with me. As I move my graph up, down, to the left, to the right, reflecting, obviously my vertical asymptote might change. So now what I want you to think, what does that vertical asymptote do to my domain and range? So if you remember the exponential function, the domain was always all real numbers. Remember how inverses, your x's and your y's change. So our domains and our range are also going to change. So now my range is the all real numbers. Sorry, I could draw this. Negative infinity, comma, positive infinity. because my domain and range are switching because they are inverses. And as you can look, there is no bound on the bottom or the top. Your domain, however, is going to start at 0, and it is going to go to positive infinity. So again, my domain and range, because these are inverses, have also swapped, okay? Your end behavior, again, if you look at it, technically, as your x's go to negative infinity, your x isn't going to go to negative infinity. Your x is only going to go to 0. So the end behavior is a little bit harder to talk about because you really don't exist. So your negative infinity for this, if you were talking about end behavior, which is a great calculus discussion, as x goes to negative infinity, my y does not exist. It is not there. And that will be a great conversation for those of you going to calculus next year. As you go to positive infinity, your graph is going to go towards positive infinity as well. So my y's, if you look up here, is towards the positive infinity range. So that's how the end behavior is affected. That is how your graphs are affected. So anytime you don't have a graph on the opposite side here, on the whole left-hand side, your end behavior is not going to exist on one side. I could reflect this, and then it's not going to exist on the other side. Okay, so hopefully those are some great observations you're making. Pause this if you need to write down any of that. All right, so here is our examples. What I know there is a lot on this slide. So let's start with what I want you to be focused on. What I would like you to be focused on is what I added in writing here for you. I should have mentioned this in the beginning. This whole slide was attached to your Google assignment. And so you could have found this and you can write this down as we go along. Okay, so this is your formal. All transformations are affected this way. A, B, H, and K are still doing the exact same things that they always have. A is talking about your vertical stretch, shrink, and reflection over the X. B is your horizontal stretch, shrink. It's the opposite of what you think. If it's a 2, it's a compression. If you have a half, it's a stretch. And then it's the reflection over the y. So again, that is your difference between your growth and decay of the exponential functions. Your right and left for h and up and down for k. So that didn't change anything. So here is your natural log equation. If I give you this natural log and I ask you how this transformed it. So I do want you to realize a lot of times with log, the k is out in front. So here would be your k, here would be your a, and then here would be your h, and here would be your b. So h and b don't exist, so there's no horizontal transformations at all. You only have vertical transformations. This is a positive 2. So you can see how they rewrote it here to help you. This was a positive 2. So positive 2 and a negative 3. So you should be thinking reflecting over the x, stretching because of the 3. The negative 3 falls into that A. So that has reflected over the x and stretched it. And then K is a positive 2. So I went up 2. Okay. Let's look at the next one. So here they're just showing you the graphs. They're just showing you how the graphs are affected. And so you could take a minute to pause this if you want to take a look at the graph. This is the original graph right here. This is showing you that it was just reflected over the x. And then the last graph is showing you, well, let's reflect it and stretch it and see what happens. So here is the reflection and the stretch for this last graph here. Okay. The last one is putting it all together. It is showing you the original here. And then showing you now if I move it up, flip it, and stretch it. So this puts all of the graphs together. Now what I would like you to do is try out the Pearson assignment online. Thank you.